Good morning or afternoon or evening to everyone. My name is Amulya. I am representing team Avelis and today I am going to present our project automated OMR evaluations. Firstly, what is OMR? OMR stands for Optical Marks Recognition, which is technology that automatically reads and processes marked data from bubble sheets like standardized text answer sheets. Instead of manually grading thousands of papers by hand, this system uses computer vision to instantly grade exams by analyzing photos of completed answer sheets. The system can handle large-scale testing scenarios where manual grading would take days and weeks, processing everything in minutes with high accuracy. Now, these programs are here to process photos taken in phones or cameras, handling 100 question exam across 5 subjects and grade over 3000 sheets with 99.5% accuracy. The system generates detailed analytics, performance reports and exports results in multiple formats. Now we move on to the code. Here, app.py is a file structure, the user interface. It serves as the main web based on dashboard that users interact with through the browser. It provides the drag and drop file upload system for multiple images, configuration panels to select exam versions, A or B, etc., and real-time progress tracking with progress bars. The interface displays comprehensive results through interactive charts, statistics, and grade distributions. The user experience flows from uploading images to selecting the correct answer key version, watching real-time processing, viewing results, and export data for further analysis. Moving on to the process engine, which is omr.py, where all the logic is present here. The omr.py file consists the brain of the system that performs all computer vision and image processing tasks. It includes several core functions, pre-processes images, which converts raw photos to clean standardized images by applying grayscale conversion, noise reduction, edge direction, and perspective correction to straighten skewed images. The detect bubbles a function finds all the circular bubbles on the answer sheets using adaptive thresholding and contour detection, filtering shapes by size and position to identify only the bubbled areas. Here, the detect answers improved function determines which bubbles are filled versus empty by analyzing pixel darkness and classifying each bubble as filled, empty, multiple sections, or uncleared marks. Now, let's start with the app.py interface. Let's learn more about it. While processing, the app shows progress with metric like total files, successful processing, and failed files. After processing, you get the average score, subject-wise analysis, score distributions, and individual student reports. The interface is interactive, user-friendly, and provides instant visual feedback. Now coming to the omr.py, which all the logic is present, its purpose is to core image processing and OMR evaluation logic. Like it provides all the logic and it's like the behind the scenes of what happens in the respective website. So here the main functions I'm going to describe is the pre-process image. This function detects sheet boundaries, applies perspective correction like I said, and the function detect bubbles, which is present here. It finds circular bubble shapes in the image. OMR sheet contains circular bubbles with options like A, B, C, D. So this function provides the ability to find the circular bubble shapes in that image. Now the detect answers improved function. It determines which bubbles are filled. Some might be partially filled, some might be fully filled. It checks that. Now coming back to answer key, this basically contains the answer key of the OMR sheets, the input of the OMR sheets. Now looking at the OMR system, this particular file is the critical reference file that makes evaluation possible. Here's what makes it essential. This is basically the core function. It contains the official correct answers that all students' responses are measured against. So the app.py and the OMR.py, they basically use this to check the scores in the OMR sheet and evaluate in it. It supports multiple example versions to prevent cheating through different question orders. As you can see, there is set B and also set A. So my input contains two sets, set A and set B. If we give the file of set A, it will check from set A and vice versa. So here it uses consistent 0 to 3 encoding that matches our bubble detection system. Here the design is of set, like the sets concept is used. The integration points are app.py. This file reads the file at startup to populate answer key selection. So this will just read the file, and the evaluation will be done by using this omr.py, which receives the selected answer keys and uses it in the comparison logic. So the scoring for each detected student answer gets compared against the corresponding question's correct answer. And the subject mapping is done, which combined with the question to subject mapping to calculate subject-wise scores. So the practical benefits of using this code is for the flexibility, that is easy to add new exam sets or modify existing answers. Accuracy is very good since source of truth prevents scoring inconsistencies. Maintenance and scalability is also good. Now we talk about the requirements text file. It's basically the dependency blueprint. It defines exactly which Python packages and versions our OMR system needs to function properly. The core purpose is for it to maintain the environment reproducibility, which ensures anyone can recreate my exact working environment. Dependency management is also seen here because lists all external libraries your code imports and uses. Version control is also maintained, and deployment ready is it's basically it makes installation on a single command. Now I'm gonna talk about how the uses of each file, like the key dependencies. OpenCV Python, the first library, is the computer version library for image pre-processing, contour detection, and perspective correction. And NumPy here is mathematical operations on image arrays and matrices. It is used for that. And Pillow, which is right here, it is used for image format handling and basic manipulations. Now for web interface, Streamlit is used, which creates the entire web UI without HTML or CSS or JavaScript. Now the Streamlit camera input, it enables live camera capture functionality, which we did not include in this, but it can be included, which is optional, but you can do it. Now coming back to pandas. Pandas is used for data manipulation like CSV, which we are using it now, and for student record management. Plotly is used for interactive charts to score distributions and analytics. Matplot library is like the additional plot it's used for additional plotting capabilities. Now for file handling. OpenPyXL. It is used as an Excel file creation and manipulation. Now let us discuss about the, because some round it in a light manner and some round it in a dark manner. It checks that. So the next one is conflict resolution, which handles multiple marks per question, and confidence scoring, which means assigning reliability scores to each detection. So these we have already discussed it mostly, and now I will just be showing you the output of this program. Obviously, these all are connected in a way, like if we run these, we get the output. Now moving on to running this program and displaying the output, I will be doing it right now by opening the terminal and by using this command, streamlit run app.py. Enter. And now this website is open for me. It will show me if it will let me select the exam version here. I'll be providing the example by using Sete. So now we upload the OMR sheets here. We can browse the file from here. I'll be using the image 2 and it is evaluating the result for me. It will show all the results like the average score, high score, average time, and it will also show me the subject-wise performance analysis with the grading. Then it will show me the score statistics and distribution as well. The summary results, individual student analysis, student ID, total score, percentage and grade. Now coming here, the bubble detection results. This is the main thing. So the correct answers, or basically the given answers, are in the black. As you can see, some are not that good, dots are given. But here, the circles, the program detected the filled circles and it processed it. Let me just show you the side-by-side representation of it. Just give me a second. So this is the image 2 which we have given the input as, and coming here, we'll just show it like right here. So here the image is, this is the original image and this is the corrected one, where it shows the correct answers in the green and the wrong answers and the blurs, the wrongdoing, like wrong method, it shows in the blue. So this is the overall analysis, and the question wise analysis is also provided, where it shows error for the questions which are not marked properly or which are just wrong, and the correct one it shows as the tick mark, and the cross ones, well, you know what happened. And the results can be exported by CSV, Excel or JSON. This can be in laptop. It can also be accessed in mobile, which I'll be showing you shortly. So this is in the mobile. I've already done it. This is the output in the mobile, which it will also show the exact same result. Well, you just scroll down, obviously, and it will show the same output as it showed in the laptop. So yeah, this is basically our project by Team Avelis. Yeah, that's it. So this is the project done by Team Avelis, while me, myself, Amulya, my two partners Rida and Gracia are the part of it. So thank you for listening to this and see you all next time.